Welcome to homework.
We need to find the value of the moment at the point A due to an input moment of negative 500 pounds inches on the point F. And this machine is in 3 dimensions. So we're going to be using vector components to help solve the problem. So we're going to start by looking at the free body diagram on the left and take the sum of moments about the x-axis. So the sum of moments about the x-axis is equal to 0, and we can write that as the moment m of c minus 500 is equal to 0. And solving for m of c, we'll get a moment value that is equal to 500 pounds inches. So we're now going to look at the free body diagram on the right and take the sum of moments about the point C. So the sum of moments about point C is equal to 0. And what we're going to do with this moment value that we calculated is that we're going to get its I components and we're going to get its J components. So we can use it with this free body diagram. So I'll write that negative m of c is going to be equal to negative 500 times the cosine of 30i plus the sine of 30j. And this will give us our I component and our j component for this moment on that free body diagram. So now writing this equation out, I'm going to write that the I component of m of a minus m of c plus 5 times I times b of y prime j prime plus b of zk. So these prime symbols here, if we go back to our free body diagram, you see that this y component and j component here is on their own axis compared to this one. So because we're treating this as if it's on its own y-axis, we label it with a prime symbol to symbolize that. So then we set this equal to 0. And then we can plug in this m of c value. So we'll get m of ai minus 500 times the cosine of 30i plus the sine of 30j, sorry, sine of 30j plus 5 times I times b of yj prime plus b of z k is equal to 0. And we can rewrite this in terms of just vector components as m of ai minus 433i plus 250j plus 5 times b of y prime k minus 5 times b of z j. So to solve for this component, this m of a I component, we just take the I component of this entire equation and we can set it equal to 0. So we're going to get that m of a minus 433 is equal to 0. And solving for this moment, we'll get a value that's equal to 433 pounds inches. So we're now going to find the reactions at the given points. So we go back to this equation here, and we do the same thing for the j component and the k component. So for the j component, we can write that negative 250 minus 5 times b of z is equal to 0. And solving for b of z, we'll get a value equal to negative 50. And now for the k component, we get that b of y prime is equal to 0. So we know that there's no y component on the b force. So we know that the reaction at point B is equal to negative 50K. And we're now going to say that using on the same free body diagram, you can say that the sum of forces is equal to 0, which we can write as force on B minus the force on C is equal to 0. So we can say that negative 50K minus C is equal to 0. And solving for C, you see that the force on C is equal to negative 50 pounds K. So we're now going to go back to our free body diagram. And we can go back to this one on the left and start solving for the reaction at the point D, and solving for the reaction at point E. So I'm now going to write that sum of moments about a point D is equal to 0, which you can write as 6i times E of xi plus E of yj plus E of zk minus 4i times c minus 500i plus 500i is equal to 0. And we can rewrite this in terms of just vector components. At 6 times E of yk minus 6 times E of zj minus 200j minus 500i plus 500i is equal to 0. So we're going to take the k components, and set it equal to 0. So we're going to have that 6 times E of y is equal to 0, which then means that E of y is going to be equal to 0. Then we do the same thing for the j component. So we have negative 6 times E of z minus 200 is equal to 0. And solving for E of z, we get a value that is equal to negative 33.33 pounds. And we can now say that the sum of forces on that diagram is equal to 0, which you can write as the force on C plus the force on D plus the force on E is equal to 0. And writing that as vector components, we'll get negative 50K plus D of yj plus D of zk plus E of xi plus E of zk is equal to 0. And we know the value of E of zk, or rather of E of z. So we can plug in that value. So we rewrite this, plugging in the known term. So we're going to take the I components and set them equal to 0. So we'll get that E of x is equal to 0. And now we take the k components and set it equal to 0. So taking the k components, we'll get negative 50 minus 33.3 plus d of z is equal to 0. And solving for d of z, we'll get a value of 83.3k. So we now have all the required components to conclude the final reactions. So the reaction at point B was negative 50 pounds K. The reaction at point D was 83.3 pounds K. And the reaction at point E was negative 33.3 pounds K.